Hi, I'm Pavan from Kausalya classes. This is the second lecture of complex number. In lecture 1, we have already discussed that iota is a symbolical representation of under root minus 1. And we already discussed that iota to the power 0 is equal to 1, iota to the power 1 is equal to iota, iota to the power 2 is equal to minus 1, iota to the power 3 is equal to minus iota, and iota to the power 4 is 1. So things will repeat, means if I want to write iota to the power 5, I can write iota to the power 4 into iota, and this will give me 1 into iota, that is iota itself. So it is easy to divide the order with 4, and whatever the remainder we will get, if I want to divide any number n by 4, our remainder will be either 0, 1, 2 or 3. So if the remainder is 0, the value will be 1. If the remainder is 1, the value will be iota. If the remainder is 2, the value will be minus 1. If the value remainder is 3, the value will be minus iota. So in this way we can evaluate any problem. Let us suppose I am having one problem. I have to prove 1 plus iota to the power 4 into 1 plus 1 upon iota to the power 4. What will be the value of this expression? So but first we should convert this expression in an appropriate format, like 1 plus iota to the power 4 into 1 plus, I want to rationalize this part, so 1 upon iota into iota upon iota to the power 4. So this will become 1 plus iota to the power 4 into 1 plus iota, this is iota, iota upon iota to the power 2. We already discussed that iota to the power 2 is minus 1. So we are going to put the value 1 plus iota to the power 4 into 1 minus iota to the power 4. So we already gone through the concept like a to the power m into b to the power m is equal to a into b to the whole power m. So we are going to use that concept, and this will become 1 plus iota 1 minus iota to the whole power 4, and this is a form of a plus b and a minus b. So this will become 1 minus iota to the power 2 to the power 4. So iota to the power 2 will give minus 1, and minus 1 and minus 1 will become 1. So this will give me 1 plus 1 to the power 4, that is 2 to the power 4. The value will be 16. So we can evaluate such problem in this way, and it's very interesting if you know the value of iota to the power 0 to iota to the power 4, and you can easily deduce these values by your own. But here I want to discuss one important concept, or you can say important result. Important result. Let us suppose I am having two real number a and b. So the result under root a into under root b is equal to under root ab. This kind of problem we have already discussed in indices, and this is true. This is true only when at least one of the given number a or b is either 0 or at least one of them is positive. For example, if I am having a value minus 2 into under root minus 3, so I cannot simply write minus 2 into minus 3 and the value will be under root 6. This is a wrong result. This is a wrong result. Proper way to do this problem is we have to deduce it in this way. This is a square root of a negative number, so we should write minus 1 into 2 into under root minus 1 into 3 So this will become under root minus 1 into under root 2 into under root minus 1 into under root 3. So this will become under root 6, and this is nothing but iota, and this is also iota. So under root 6 iota to the power 2. So the answer will be minus under root 6. Now in this way you can solve so many problems like under root minus 25 into under root minus 49. So you can easily write it down under root 5 iota into under root 7 iota. Once you will do the practice with so many problems, it will be easy for you to write it down quickly. So you can write iota to the power 2 under root 35. So answer will be minus 35. Now our next concept is how we can express a complex number. How we are going to express a complex number. See, a number of the form a plus iota b. The number is in the form of a plus iota b, where a and b are real numbers. A and b are real numbers, and iota is equal to under root minus 1 is known as complex numbers. So this is the way through which you can write the complex number, and set of all the complex number, set of all the complex number is denoted by capital C. Now let us suppose I have a complex number z, that is equal to a plus iota b. So a is called real part of z, that is a, and b is called imaginary part of z, that is b. For example, let us suppose I am having a complex number z is equal to 2 by 3 minus iota 3 or 3 iota. You can write in either way. This you can write, or you can write 2 by 3 plus 3 iota. So real part in this case, real part of z is 2 by 3 and imaginary part of z is minus 3. So a complex number consists of a real part as well as an imaginary part. So if you are talking about purely real or purely imaginary, purely real complex number, in that complex number the imaginary part will be 0. It means, let us suppose I am having a complex number z is equal to a plus iota b. So if I want to write purely real number or purely real complex number, if I want to write, so in that context imaginary part will be 0. So for purely real number, imaginary part of z will be 0, and for purely imaginary complex number, the real part of z will be 0. And example for purely real number, the purely complex number will be 2 minus 7 under root 3 and so on. And purely imaginary complex number will be like 2 iota under root 3 iota minus 3 by 2 iota and so on. Now our next concept is conjugate of a complex number. How we are going to write a conjugate of a complex number? Conjugate of a complex number. Let us suppose I am having a complex number z, that is equal to a plus iota b. So the conjugate is represented by z. So z bar is conjugate of z, and z bar over bar is conjugate of z bar. So z bar is a conjugate of z, so it will be equal to a minus iota b. So what we are doing, we are changing the sign of, we are changing the sign of imaginary part of z. Here the imaginary part of z was v, so we change the value plus v to minus v. Next concept is modulus of a complex number. Modulus. Modulus of a complex number. Let us suppose I am having a complex number z is equal to a plus iota b. So modulus of z is represented by mod of z, and that is equal to under root a square plus b square. For example, z is equal to 2 plus 3 iota, then mod of z will be is equal to 2 square plus 3 square, and answer will be under root 13. Next concept is equality of a complex number. Equality of complex number. Equality of complex number. Two complex number. Let us suppose I am having two complex number. Z1 is equal to A1 plus iota B1 and Z2 is equal to A2 plus iota B2. So if two complex number Z1 and Z2 are equal, it means A1 will be equal to A2 and B1 is equal to B2. For example, if 2y plus 3x minus y iota is equal to 5 minus 2 iota, find the value of x and y. So we should compare the real part. As we can see here, in this situation two complex number is equal to each other. Let us suppose this is z1 and this is z2. z1 is equal to z2. So real part of the complex number will be equal to real part of the another complex number, means 2y is equal to 5 and 3x minus y is equal to minus 2. So here we can get y is equal to 5 by 2. We are going to put this value over here. We will get 3x minus 5 by 2 is equal to minus 2. This will give 3x is equal to 5 by 2 minus 2, and the answer will be 2. 5 minus 4, so answer will be 1 upon 2. So 3x is equal to 1 upon 2 means x is equal to 1 upon 6. So if two complex numbers are equal to each other, it means the real part of the one complex number is equal to the another complex number, and imaginary part of one complex number is equal to the imaginary part of the another complex number. Now we should proceed to the another concept, and that is sum and difference of complex number. Sum and difference of complex number. Sum and difference of complex number. Let us suppose if we have two complex numbers, z1 is equal to a1 plus iota b1 and z2 is equal to a2 plus iota b2. So if I want to add these two complex numbers, we are going to add it simply as we are doing in algebra. A1 plus iota b1 plus a2 plus iota b2. So we are going to club real parts together and imaginary parts together. So iota b1 plus iota b2. We are going to take the iota common. So a1 plus a2 plus b1 plus b2 iota. So we can see here z1 plus z2 will give the sum of the real parts plus sum of imaginary parts. If I want to subtract two real numbers, two complex number, the result will be like this: z1 minus z2, a1 plus iota b1 minus a2 plus iota b2. So first we should open the bracket, a1 plus iota b1 minus a2 minus iota b2. So we are going to club the real parts, a1 minus a2, and we are going to take iota common. So the result will be b1 minus b2. So in case of addition, the real part will be add up and imaginary part will be add up together, and in subtraction, one real part of one complex number is going to be subtracted from the another, and the same will happen with the imaginary part also. So in the case of plus and minus, we can do this. Here are few properties of addition of a complex number. So the topic is uh, properties of addition of a complex number. Properties of addition. Properties of addition of complex numbers. Properties of addition of complex numbers. Now, the first property is closure property. Closure properties. Closure property says that the sum of two complex numbers is always a complex number. Means let us suppose I am having a complex number z1 and another complex number z2, then the result will be a complex number only. And you can verify this property by choosing any two different complex number. You should do it by your own. The second property is commutative. Commutative law. Commutative law or commutative property says, let us suppose I am having a two complex numbers z1 and z2. So z1 plus z2 is equal to z2 plus z1. This can also be verified with any two different complex number. You can choose two different complex number by your own choices. Third point is associative law. Associative law says, let us suppose I am having three different complex numbers z1, z2 and z3. Then z1 plus z2 and result is going to be added with z3 will be equal to z1 is going to be added with the result of z2 plus z3. For this for the verification of associative law, you can choose three different complex numbers. The fourth property is existence of additive identity. Existence of additive identity means what we should add to a complex number so that the value of complex number is not going to change. So 0, if we are going to add 0 into the complex number, or 0 if we are going to add complex number to 0, the value will be complex number itself. So it's very easy. If you want to write down a complex number, how we are going to write down a 0 as a complex number? 0 plus iota 0 you can write for your choice. Now the next property is sixth property. Total property we have gone through. Fourth property we have discussed. Fifth property is existence of additive inverse. Additive inverse. What it says? It says for every complex number z is equal to a plus iota b has minus z, means minus a minus iota b, right? Or you can write minus a plus minus b iota, you can write, as its additive inverse. Means if you are going to add z plus minus z, you will get 0 only. Either way it is true. If you are going to add minus z with z, or you are going to add z with minus z, the answer will be 0 itself. So this is called, minus z will called additive inverse of z, and z is called additive inverse of minus z. Now our concept is to multiply two complex numbers. We are going to multiply the two different complex number and see the result how we are going to get. So topic is product of complex number. Product of complex numbers. Let us suppose I am having two complex number. Z1 is equal to a plus iota b and Z2 is equal to c plus iota d. So Z1 into Z2 will be equal to a plus iota b into c plus iota d. I am going to multiply a with c. It will give me ac plus a with id plus iota b into c and iota b into iota d, and answer will be ac plus ad iota plus bc iota plus bd iota square. Iota square will give the value minus 1, so this will become minus bd. So ac minus bd will be the real part, and plus ad plus bc will be the imaginary part. So you can derive this value easily by your own. No need to by heart this format. Let us suppose I am having two, for an example, I am having two different complex numbers. Z1 is equal to minus 2 plus 3 iota and Z2 is equal to 7 minus 5 iota. So if I want to multiply Z1 and Z2, what will be the answer? Answer will be I should multiply a with C. So this will give me minus 14 and minus b into d. So this is b into d. So this will give me 15 minus 15. It will give you minus 15 and plus. Minus and minus will become plus. This will become 15. So this will be the real part plus imaginary part a with d. So this will give me 10 iota and plus b and c 21. So plus 21 iota. So the answer will be 1 plus 31 iota. So this is the way through which you can multiply two complex number. And here also we are having so many properties of product of complex number. Properties of product of complex numbers. Once again, the first property is closure property. Closure property says if I am going to multiply two complex number, the result will be complex number itself. The second property is commutative property. Commutative property says if I am going to multiply z1 into z2, this will be equal to z2 into z1. Third property is associative property. Associative law, or you can say property. Associative property says if I am having three complex number, then z1 z2 multiply with z3 is equal to z1 multiply with z2 z3. Fourth property, existence of multiplicative identity. Existence of multiplicative identity. Existence of multiplicative identity says for every complex number z, that is equal to any value a plus iota b, we have a complex number. If existence of multiplicative identity says what number we should multiply with a complex number so that the multiplied value is not going to change. So simply you should multiply with 1. 1 is going to be multiplied with any complex number. Nothing is going to happen. Identity of complex number will retain as it is. So we should multiply for every complex number z is equal to a plus iota b. There should be a number 1, that is 1, which is going to multiply with complex number, and the result will be z itself. So 1 is called additive identity. Now the fifth property is existence of multiplicative inverse. Existence of multiplicative inverse. In earlier cases, in addition, we have discussed about additive inverse. Here we are discussing multiplicative inverse. So multiplicative inverse says what number we should multiply with a complex number so that we can get a value 1. Let us suppose I am having a complex number z that is equal to a plus iota b. So what we should multiply, let us suppose I want to multiply x with z and the result should be 1. So I am interested to find out the x. So x will be nothing but 1 upon z, and here the 1 upon z is nothing but a plus iota b. We should rationalize this value, a minus iota b upon a minus iota b. So numerator will become a minus iota b and denominator will become a square minus b square iota square. Iota square will give you the value minus 1 as you have already discussed. So the 1 upon z will be going to multiply with z, then the answer will be 1. So 1 upon z is basically the multiplicative inverse of z. So 1 upon z is a minus iota b upon a square plus b square. Okay, so if you will see this value closely, our z was a plus iota b and numerator is a minus iota b. So numerator can be written as conjugate of z, and if you will see the denominator can be written as under root a square plus b square to whole square, because under root a square plus b square will become mod of z to the power 2. So multiplicative inverse, let us suppose I am having a complex number z, then multiplicative inverse will be 1 upon z, and the value of 1 upon z will be conjugate of z upon mod of z to the power 2. So this is the idea which we are going to use further to divide two complex number. The next concept is that is the sixth concept, and that is distributive law. Distributive laws. Distributive law says that, let us suppose I am having three complex number z1, z2 and z3. So z1 into z2 plus z3 is going to give me z1 z2 plus z1 z3. Okay, and if I am having a value z1 plus z2 is going to multiply with z3, then this will be equal to z1 z3 plus z2 z3. So this is a distributive property we are doing in a same fashion what we did in algebra, right? You can say this. It's clearly visible that we are doing the same thing what we did in algebra in our early classes. So our next concept is quotient of two complex number. How we are going to divide two complex number? It's very easy, because you have gone through the idea of complex number step by step, so you will not feel any problem while dealing such problems. So quotient of two complex numbers, and quotient of two complex numbers says, let us suppose I am having two complex numbers z1 and z2 in such a way that z2 is not equal to 0, then we can write z1 into 1 upon z2. In place of z1 upon z2, we can write z1 into 1 upon z2, or further we can say z1 into z2 to the power minus 1. And we know that z2 inverse, or you can say this is the multiplicative inverse of z2, so it will be conjugate of z upon mod of z2 to the power 2. For example, let us suppose I am having z1 is equal to 6 plus 3 iota and z2 is equal to 3 minus iota, then the value of z1 upon z2 will be 6 plus 3 iota, and conjugate of z will give me 3 plus iota upon under root 3 square under root 3 square plus 1 square to the whole square. So square and under root will get cancelled, and z1 and z2 here we can solve. This value will be 6 plus 3 iota, and this value will be 3 plus iota, and constant term 10. This will give me 10. So 10 will be outside. So 1 upon 10. So we can simply multiply these two complex number as we have done in earlier concept. So 1 upon 10 is equal to 18 plus minus 3 plus iota 9 plus 9 and plus 6. So 15 plus 15 iota. So the answer will be 15 upon 10, 1 plus iota. So the answer will be 3 upon 2 plus 3 upon 2 iota. So this will be the division of two complex number. You can use this idea to divide two complex number. It's very easy. You can easily do this such kind of problem you can easily handle. Now some useful expansion I am going to give you as homework. You should try by your own and use the logic which you have already gone through the concept of complex number. So some useful expansion, you can say expansion, some useful expansion. The first expansion is z1 plus z2 to the power 2 is equal to z1 square plus z2 square plus 2 z1 z2. You can choose any value of z1 and z2 to verify this result. Second, z1 minus z2 to the power 2 will give you z1 square plus z2 square minus 2 z1 z2. Third result is z1 square minus z2 square is equal to z1 plus z2 and z1 minus z2. Fourth, z1 plus z2 to the power 3 will give you z1 की power 3 plus z2 की power 3 plus 3 z1 square z plus 3 z1 z2 square. So these 4-5 problems you should try by your own. You can easily deduce and solve these problems by choosing z1 and z2 different values. z1 and z2 to the power 3 is equal to z1 to the power 3 minus z2 to the power 3 minus 3 z1 z1 minus z2. So you should solve this problem by your own. There are a lot of problems which you should solve for an exercise. If you are interested, you should test me. I will give you the question bank of complex number. Let us suppose it is given express 4 minus 3 iota to the power 3 is in the form of a plus b iota, is in the form of a plus iota b. So expand this. This is in the form of a minus b to the power 3. So a to the power 3 plus, sorry, this is a minus b to the power 3. So we should write a to the power 3 minus b to the power 3 minus 3a minus b. So this will be 48 and this will be 27 iota to the power 3 minus this is 12, 36 iota 4 minus 3 iota. So when you are going to solve this, 48 and this will become minus iota, so minus will become plus, 27 iota minus 36 into 4, 24 and 14. So 144 iota minus plus 36 into 3 will be 108. So minus plus 108 iota to the power 2. Iota to the power 2 will give you the negative value. So 48 minus 108 plus 27 minus 144 iota. So this will give you the value minus 44 minus 117 iota. When you will subtract 108 with 48, you will get 44 plus minus minus, and 144 minus 27 will give you 7, and 13 minus 2 11. So yes, we have written correctly. Yes, so the value of A will be minus 44 and the value of B will be minus 117. So if you want a question bank of complex number, you should test me. I will give you the result. We are having two or three more concepts which we are going to deal in our next lecture, in lecture 3 or 4. Thank you.